Welcome to this machine learning case study. Today, we're going to be covering the paper titled A Novel Decision Support System for Designing and Assessing Phytoremediation to Biofuel Value Chains. So a little bit of an introduction. The worldwide biofuel demand is expected to increase by 20 to 30% by 2028. And suitable energy crops for biofuel production can be grown on contaminated land to help meet this demand. Benefits of this include that there is no competition between biofuel production and agriculture. It decontaminates the soil through phytoremediation. There is increased soil productivity and quality due to land restoration. And it avoids a lot of the negative impacts to soil and water ecosystems as well as human health. The growth patterns of high biomass producing plants on contaminated land is understudied and largely unknown. So the goal of this study was to use supervised machine learning to make predictions using existing data on various factors, including soil contaminants and geographic locations. It enhances the potential for applicability in real life where each contaminated area has different characteristics. The machine learning module was trained on data from past field trials conducted on contaminated land. Inputs included geographic location, average soil contaminant levels, soil pH, soil organic matter content, and selected species, while outputs, or the factors that were predicted, included species suitability, biomass yield, biomass moisture, and levels of contaminants in harvested biomass. So the initial algorithms that were used included support vector machines, linear regression, artificial neural networks, including shallow and deep feed forward architectures, and k-nearest neighbors. The resulting relative absolute error scores, however, were over 200% on the training data set, and this poor performance could be due to data scarcity. The most important variables identified were geographic area, plant type, and soil pH. So the authors took this data and developed a custom-made one nearest neighbor classifier regressor. This new model calculated the nearest data point within the training set to the test data instance and chose the output variable with the shortest distance from the test instance. This resulted in a relative absolute error score that was less than 20% on the test set, so it performed a lot better than the initial prediction. This shows the estimated biomass yields of each species. Reed canary grass yielded about 3,800 kilograms per hectare of biomass. Miscanthus yielded 15,300. Short rotation coppice willow yielded 5,700. And switchgrass yielded 11,050 kilograms per hectare of biomass. The authors conclude by stating that this machine learning model helps simplify feasibility assessment of a phytoremediation to biofuel value chain to inform policymakers. And phytoremediation-based biofuel production is financially viable and competitive with commercial fuel production when biomass yields are high over large-scale cultivation areas. So that has been this case study. If you're curious to read through the paper and learn more, you can find it at this full citation. Thank you for watching.